So what do you see as the biggest opportunities for model-based deliverables, particularly up to fabrication levels? And can you speak to some of the terminology like LOD for those in the audience who might not be familiar?
So I think, really started investigating model-based deliverables more than a decade ago, and it was in response to kind of how the industry was shifting through the advent of technology. So architects were starting to be more ambitious in their designs, exploring more shapes, less orthogonal structures. Contractors were looking to use technology across the board, and then of course there's schedule pressure. So our schedules, in terms of design, were probably half of what they were a decade ago, and contractors are delivering buildings faster and faster. So,
welcome to this episode of the AEC Engineering Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. Did you know that construction projects worldwide exceed their schedules by an average of 20% and their budgets by a staggering 80%, according to recent industry studies? Delays and inefficiencies have long been a challenge in the AEC industry, but an innovative solution is emerging: model-based deliverables. These digital tools have the potential to revolutionize the industry by streamlining workflows, enhancing collaboration, and delivering unparalleled precision, ultimately reducing delays and inefficiencies. In today's episode, I'm thrilled to welcome Aaron White, Chief Information and Digital Officer at Walter P. Moore. Aaron is at the forefront of digital transformation, pioneering the integration of innovative technologies to improve outcomes in engineering and construction. Together, we'll speak about how model-based deliverables are not just solving long-standing industry problems, but also creating opportunities for fabrication-level accuracy, seamless coordination across multi-material models, and faster, more efficient construction workflows. I'm your host, Nick Heim, and this is the AEC Engineering and Technology Podcast. With that, let's jump into today's episode. It's now time for our conversation of the week with Aaron White. Aaron, thank you so much for taking the time to join the show, and welcome.
thank you, Nick. Thanks for having me.
Absolutely. So this is going to be a really nice episode. I was just talking with Aaron about a couple of the questions previously, so there's a lot to get into here, and we'll just kick it off. But Aaron, can you start by telling us a little bit about yourself and what led you to your role as Chief Information and Digital Officer at Walter P. Moore?
Yeah, sure. Thanks, Nick. I've been at Walter P. Moore now for 27 years. I'm a senior principal in the Tampa office, and I'm a structural engineer by training. So when I joined the company back in '97, I joined because of the types of projects that we worked on. I really enjoy kind of big, complicated geometries, fast-moving projects. So I've been very fortunate to work across a lot of different industries: sports, themed entertainment, aviation, convention centers, federal government, and higher ed, et cetera. And then I've also been very fortunate to work on a lot of different contractual arrangements. So design build, IPD, and of course, traditional CMAR or design bid build. And early on, I was kind of just engaged in technology, new programming from school and stuff like that. So I was really good in Excel and AutoCAD, and worked with a couple of our folks to kind of create some custom interoperability solutions. And then in 2002, got involved in exploring BIM, including things like Aviva, which the EPC industry used, and Tekla XSteel back at the time. Continued on delivering projects and starting to get more senior on projects and managing them now, and working on really some interoperability solutions for structural engineering, which is a big challenge for us as engineers when we're moving data from analysis models to documentation models to conceptual models and things. Explored Grasshopper at the beginning, like 2010, 2011, and then took on a role called Director of Digital Practice in 2014. And at that time, Walter P. Moore was kind of expanding our different areas of practice. So we added in construction engineering, enclosure engineering, secure design. And so my role was really about integrating those the data from those different design arms of Walter P. Moore. And been pretty successful in that over the past 10 years. And then just this past October, took on the new role that you mentioned, the CIDO role. And I think early on, I was very fortunate to work with a guy named Larry Griffiths, who was a mentor of mine. And he made the point to me probably in year 3 or year 4, saying, hey, it's great if Walter P. Moore is successful in a project, but we don't really consider it a success if the architect's vision isn't realized, if the contractor isn't successful, if the steel fabricator and erectors aren't successful. And so that was really kind of hammered into me early on, that the success is about the project, right? And getting those design ambitions and just the construction safely done and on time and on budget. So really, my role now is really kind of partnering with folks both inside the company and outside the company, and kind of reinventing our industry.
And Aaron, it sounds like you're getting exposure beyond, let's say, what your practice area was before kind of moving up in the company, right? So it sounds like your practice and your practice area is new design, but you've gotten exposure to other areas of the company through just moving up the ranks.
Yeah, exactly. And certainly on some of those bigger projects, right, you got expansions, you got renovations. And so you do get into some of that existing work and retrofits. And then, just again, working on bigger projects, you get exposed to a lot of different trade partners, a lot of different consultants and things. And probably one of the best exercises for me was I was fortunate to work on the Arizona Cardinals NFL stadium early in my career. That was a design build job where Walter P. Moore was actually underneath Schuff Steel. So we got to work directly with the steel fabricator in coming up with the designs and connections and details and everything. And that really opened my eyes to the possibilities of collaboration, right? Before that, I was kind of always underneath an architect, working with a design team, but not having a lot of exposure to those in the field that were, coming up with or actually building it, right? And so on that job, we built the roof kind of on the ground, about half the roof, about 6,000 tons of steel, and then they lifted it up into place. And so that was just an amazing experience that really opened my eyes to the possibilities.
And I can even speak, beautiful stadium. I was actually there for the first time this past October. So I can speak to it, but that's actually a great segue into our next question, Aaron, because we all know this industry comes down to communication. One of the ways to communicate are through model-based deliverables. So what do you see as the biggest opportunities for model-based deliverables, particularly up to fabrication levels? And can you speak to some of the terminology like LOD for those in the audience who might not be familiar?
Yeah, sure. So I think, really started investigating model-based deliverables more than a decade ago. And it was in response to kind of how the industry was shifting through the advent of technology. So architects were starting to be more ambitious in their designs, exploring more shapes, less orthogonal structures. Contractors are looking to use technology across the board. And then, of course, there's schedule pressure. So our schedules, in terms of design, were probably half of what they were a decade ago, and contractors are delivering buildings faster and faster. So we kind of knew something had to change in the first place. And then secondarily, as the advent of BIM and Revit really kind of took over, a lot of folks were initially using BIM as CAD. So they were just doing the same thing that they were doing in AutoCAD, but happened to be in Revit. And the deliverables were drawings, and drawings in a lot of ways are basically to a level of development of LOD 200, which means you model an element inside of the software, and it's pretty close to being right. It may not be exactly in the right location, but it's good enough for 1/8-inch scale plans or 16th-inch scale plans. And you might know the members, a W14 by 90 column or a 24-inch deep concrete beam, but it may not have a lot of additional information in there. And that's kind of the standard for the industry right now, is this idea of LOD 200. LOD 300 takes you to the next level, where you can really rely on the information in the model to tell you everything about the physical location where that member is. So that includes materiality, it includes exact geometry. So if you think about, like, let's say a precast parking garage where you have a double T, that double T should be sloped, it should be warped, right? Because it's actually the shape that it will be in the final condition. And that's a little bit challenging to achieve inside of Revit, but it can be done. And that's super important if you're trying to coordinate, fire protection or drain lines or something else. You need to know exactly where that double T is. So again, LOD 300 is precise location. And a lot of engineers and architects don't live up to that requirement because it's not really useful to a whole lot of people unless you're giving them the right of reliance for the model. Take us to the next level above that is LOD 400 level development, which is you're modeling everything that is needed for the fabrication or assembly of that element. So that's going to be like in a steel condition, every plate, every bolt, every weld, every bolt hole, every chamfer. In concrete, it's every piece of rebar, the ties, the longitudinal bars, the dowels, hooks, everything exactly as they need for fabrication and assembly. even to the point where in steel design, like if you're doing a long span truss, they may ship it with some erection bolts. Those erection bolts will be modeled, even though they're not there in the final condition. So with that kind of level set, then the opportunities are pretty significant for what we can do there. You can think about, at a high level, you can think about robotics. Now we have exact information that we need to feed into the robots to, actually deliver out on site. You've got options for, prefabrication, modularization, things like that. There's also opportunities to really kind of reformat the entire approach to delivery. And what I mean by that is right now, let's take the steel industry. The way it works is the engineer will release a bid package, right, of drawings, and then the GC or the CM will go out and bid those drawings, which takes a couple of weeks. And then the successful steel fabricator will hire a steel detailer who will then model the building, right, to an LOD 400, and that takes time. So throughout that entire process, you've got about 6 to 8 to 12 weeks of time before you actually have something actionable from the steel detailer in terms of ordering steel, if it's a big project, right? So if we kind of flip that on its head and bring the steel detailing up ahead of the bidding process, now the engineer or a third party can be modeling that to a LOD 400 level, and then you can use that fabrication level model for bidding. And that's kind of one of the big opportunities that we've seized on a number of projects, and it's been pretty successful so far.
Great segue into our next question, Aaron. So that's, I think, one example of how pushing it towards LOD 400 or fabrication level improves project outcomes in our industry. Are there any other ways where like integrating metadata is helpful that you can share with the audience?
Yeah, so metadata is really just, information about data, right? So if I have a steel beam or a steel column or a concrete beam or column in my model, I'm going to be packing a bunch of information into that model. And as designers, we know a lot of that information, but also working with contractors and pre-estimation teams, they can inject or give us information to inject in the model. So there's lots of opportunities to put really good data into the model that just allows the model to be very clear in terms of design intent, in terms of complexity. And so just like one simple example is if you think about like steel coatings and surface preparation, right? So right now, the way it works is you go out with a set of drawings and you have a set of specifications, and the set of specifications may say, hey, any steel that's exposed to the atmosphere, needs to be galvanized or something like that. Anything that's going to be fireproofed gets this SPC2 coating or whatnot, right? And so somebody has to go through and make those decisions. And right now in the industry, that's kind of left up to the detailer to try to figure out and guess or estimate what the right coating is or the right surface prep is. And then that goes through the shop drawing process, and maybe the architect checks it, maybe a young engineer checks it from the engineering side, and hopefully it's right. In a model-based environment, you open up the model, you look at the model, you can walk through with the architect directly and just say, hey, this whole group of columns needs to get galvanized. This whole group of columns is going to be fireproofed, right? And then putting that information directly in the model makes it very clear for anybody, an estimator, an owner, a detailer who's looking at the model, what the information is now, right? There's no guessing, there's no confusion, and there's no risk because it's very clear. So if you're an estimator, you now don't need to throw a big number at galvanizing because you know exactly those 16 members are galvanized or whatever, right? So that's a big aspect of it. I think the other big thing is we're eliminating in a lot of ways delegation. So traditionally, the way to kind of go fast was to delegate, design down to the subcontractors, and then they would pick it up because they're the ones that were most efficient to do it, right? But in a lot of ways, that causes problems in late changes, late inputs. So in some cases, what we'll do is early in schematic design, if we've got some connection, let's say at a airport or a sports project that's going to be exposed, we'll actually take that connection all the way up to LOD 400 during schematic design. And we'll do it that way. We'll bring it to LOD 400 in 3 or 4 different versions, right? So there might be one with an end plate. There might be one with a gusset plate. There might be one that minimizes the amount of bolts. There might be one that has many more bolts, right? And then we show that to the team, and they can make a decision on what is the aesthetic that they want for this. Contrast that against the old way of doing it, which would be just to show the steel members coming together and then wait until very end of the game. Maybe in CDs, the engineer might design it, or they even delegate it to the steel fabricator, and you don't really know what you're getting. So in terms of pricing that connection, we now know up front, because we've studied 3 or 4 options and we've picked one. We put that right on the drawings. We say this is the intent, right? And so now a steel fabricator or a pre-con estimator can say, okay, that looks like $7,000 a ton versus $5,000 a ton, and we kind of eliminate a lot of the risk associated with the exploding cost, the unit cost of steel, just by providing that clarity, by showing those high-level models early on. Even if we throw them away later on, we've explored options, and now we've provided clarity to the things.
It sounds like you guys are pulling the future forward, because all of these last minute decisions, or as you get closer to construction, right? Because it has to drive the cost up. The later you make a decision, the more it's going to cost.
Right. Yeah, definitely. And that goes for, anything like secure design where you're getting late inputs. It could be precast, any kind of decision that you're making where a late input will have a rippling effect to lots of previously made decisions. We want to bring all that stuff as forward as we can. Steel erection is another great example, as we try and build in the intelligence or the thought process of steel erection right into the design through LD 400, and be thinking about all those things that could cause problems later on from a schedule or a procurement standpoint.
And Aaron, this new way of thinking, or at least a way that's not commonly practiced, sounds like it has a number of benefits, right? But as an industry, we're not always the best at accepting or implementing change. So what are some of the key challenges you see in our industry today related to adopting model-based workflows?
Yeah, I think the first one is just that willingness to change, that mindset. If we think about how efficient the current process is, right, going back to the 60s and 70s, we've really kind of squeezed all of the efficiency out of the current process. So we want to go faster at higher quality with less risk. We have to do something different. And so we've seen, in terms of presentations, when we're talking about this process, that people are interested in it, but they still are a little bit concerned, right? And they don't necessarily trust it. One, because it's something new. It changes contractual obligations. It changes incentives a little bit. So I think there is a lot of trust in that first time you do this. And then once you get that taste for the new way of doing things, you go, okay, this is really interesting. And I think as you go through maybe the second iteration or third iteration, your eyes are open to the possibilities, because now there's so many more things you can do when you get a good model that can be trusted and relied on from the designers or a third party in this overall process. So another thing would be, talking about challenges, is just the incentives. I was working on a project a couple of years ago where we had this very complicated construction of a wall. It was a 5-foot thick wall, had embedded steel columns in it, and a bunch of rebar that was going in there. And the engineer said, okay, that's kind of means and methods. You guys figure out how to build it. The steel detailer said, well, the steel is there, and the rebar detailer, wasn't really able to help the process either. So none of them were incentivized in helping the contractor actually, figure out a way to build the structure out in the field. So the steel detailer is happy just to crank out their steel. They're on to the next project. They have no incentive to try and help this. The rebar supplier just sends the rebar out to the field. They figure it out, and then the engineer designed it. So the incentives to really come up with a good design that is buildable by all parties is still a little bit of a limitation. And then as you think about this, pulling together multiple materials or multiple trades, the incentive to collaborate, right? That's a challenge for us. I think also just standards in general, right? Understanding how the different trades will actually fabricate their materials or create their materials. And just one simple example is in the steel industry, right? If you model a steel beam, let's say from north to south versus from south to north, that has some impacts to the actual process and in terms of like shop drawings and other things. And so they may need to go in and flip that beam to get it to show up appropriately in shop drawings. So whoever's creating that model initially has to know that, right? So there's a lot of standards there that the people need to get familiar with if they're going to be creating LD 400 models. Otherwise, they're kind of worthless or have to get recreated anyway. I think the final thing I'll say about the challenges here is really around incomplete models. So if you're at SD, you don't have every expansion joint modeled. You don't have every curb modeled. So if you're trying to take off quantities in your models early on, they're incomplete. And so I think the response from contractors in a lot of ways is, well, put it all in there. Well, we don't know it all at SD. So we have to have contingencies, we have to have allowances. And so this understanding that there's information that's going to be in the model at CDs that isn't in their SDs is a bit of a communication challenge or something we need to figure out as an industry.
Good follow-up question here, Aaron. So what strategies do you recommend for ensuring model content aligns with its intended purpose? Because like you said, if the information is either there and it's incorrect, or if it's not there at all, the value of the model seems to decrease.
Yeah, certainly the biggest thing there is just communication, having a written down plan about the purpose of the model and what the models can be used for and what it shouldn't be used for. And this goes beyond kind of your traditional LOD matrices or BIM execution plans, right? That don't really get into that. They just kind of talk about the right of reliance. So this would be very clear that the team that's getting receiving a Revit model for purpose of estimating, they know what's in the model, what's not in the model. In a lot of these projects, we actually, as the designers, we actually provide quantity information, square footages, tonnages, cubic volume of concrete on a deliverable, a drawing or something else that is separate from the model. So, is the model the basis of truth, or are these quantities the basis of truth? And just understanding that. I think a lot of early on discussion about the value of this. In my previous position, I saw a lot of BIM execution plans that called for let's make up something and say, at DD we needed foundations to be LOD 300, right? But there's really no value in having LOD 300 foundations at DD, right? You're not going to be going out. You might be bidding something, but you can't necessarily get there. And with certain D foundations, you can't even be at LOD 300. It's impossible unless you go out and actually have a pilot hold every single boring location or whatnot. So just the realities of what our contracts are asking for, I think is important. And then I think to revisit that plan, that communication every step of the way, because as you get closer to design or the completion of design and construction coming on board, there's more teammates coming on. And so they're going to be just thinking the old way of working. And so they need to understand the plan and why this is a good thing or why we're trying something different and really buy into that.
And Aaron, I'm hearing a common theme of communication across all of these questions, because that's, essentially what our industry boils down to. But who should be responsible for providing these project models? And then how should these models be coordinated across these different project teams and stakeholders?
Yeah, so I think, realistically, anybody can provide these models, which sounds kind of weird, but let's just say you could have a third party create these models. The biggest thing I think what we want to do is separate kind of the detailing or the LOD 400 model from the actual fabrication and separate those two, because that's where you introduce a lot of risk by having to hire the fabricator or the builder of that scope just to get the detailing. Okay. It'll probably come as no surprise as a design team member. I think the design team is in the best situation to actually create these models. And the reason for that is if I'm going to hand off something to give it to a third party to create these models, there's always going to be a lag there, right? Between when I produce my deliverable to the person who's building the model and then they build the model, there's always a reaction, even if it's a week, 2 weeks, 4 weeks, whatever it might be. If I own the model in-house, then as part of my design process, I understand where I'm done with design, where, the design is reasonably settled down, and maybe now we can take that to LOD 300, we can take that to LOD 400, while I'm still working on this other section in completing the design there. So it gives me a lot of flexibility in terms of how the design side can deliver these models. So that's part of it. I'd say if you do go to a third party or have somebody else do it, you do have to allow for the rework, the flexibility. One of the things we didn't talk about earlier in terms of the benefit of the model-based deliverable is really for the contractors to kind of play out some different scenarios and how they may deliver and sequence the project. And so if we do that, if we explore, we could build this portion first, or we build this portion first, that means we're probably going to have a couple of do loops where we cycle back around and revisit a design element or reconfigure rebar or steel or something like that as part of the process. So we have to understand that the goal here is to come up with the best way of build the building virtually and then build the building once out in the field. Right. So I'd say we're just going to be set up for rework and flexibility. There's a little bit of fee built into that to let the field go really fast. Going back to the idea of communication, major coordination issues have to be ironed out early, right? So that is a focus, and we're going to stick to those decisions. One simple example of that is does the conduit go in the slab, or does it go, is it hung underneath, right? That can be a key decision. But very frequently, you go out to a job site, and next to the switchgear or something, there's a ton of conduit, right, that doesn't meet the requirements for the structural engineer. And so we're fighting about that. There may be a delay in the pour. There may be more rebar needed or something else. So those types of things in a multi-material LD400 environment can get solved pretty early on and kind of stuck to.
And Aaron, to this point, I think we've been viewing this discussion generally under the guise of new structures. But I want to ask, how do renovations or expansions of existing structures impact the coordination and delivery of multi-material models? And do you see any differences or challenges when compared to new design?
Yeah, I think this is part of the most exciting area for this advent right now is just reality capture and being able to go out to job sites and acquire the data from the field and be able to rely on that and convert it into information. So a couple of points, I guess, about your question. One is just understanding the tolerances of, what's out in the field and how good is our reality capture, and are we able to convert that into anything meaningful that the design team can use. But secondarily is just the tolerances of the new construction, right? Everything in LD400 is super precise, but we know that's not the case when we go out to the field. So, if you've got a new column going in it right up against an adjacent wall or something like that, you have to allow for tolerances. So you can't just go snug up against that. So one of the discussions with existing work or renovation work is just how is the model going to interact with this, real world environment? When you've got the reality capture, there's a lot of great data in there that we can pull into the models and rely on. But I definitely think you go out and still check some things, make sure that the reality capture worked really well. But man, this is a fun time for reality capture and just seeing the explosion of the technology there, how much better it's getting. I do feel like there's a big opportunity for going back to our earlier conversation about putting metadata into the model, and just let's take one example of, let's say, a precast parking garage or a cast in place parking garage, where you're going out and doing some reality capture, and now you've identified a bunch of cracks that need to get routed and sealed or whatever. If that's in the model, now you can track that fix the whole way through the entire construction process, right? So instead of having like a specification that says you're going to use this product, you can tag that crack right with the products or, the construction procedure that they need to follow or whatever. And then the contractor can use the model to then, say, hey, we implemented, this on, January 17th. We went back and checked it. It was inspected on the 20th. And then, it was caulked or whatever those processes are, and use the model much more as a digital twin to track progress and just be, more intelligent about how we're tracking the whole construction and renovation process.
And just because this is my field of practice, right? A great example of that is, say, your initial reality capture identifies cracks using manual or computer vision, right? You go through the construction process and you redo that same capture. So you can compare the two stages in time and actually see, yes, like all of these were touched, or no, there are some missing. Giving you that global view, I think that's a little tough to just do when you're just going, defect by defect visually while you're walking along through the garage.
Yeah, and I think the total length of crack. So if you want to go with product A, versus product B or whatever, and how long that product A is good for versus product B, like you can really start building in life cycle costing and other opportunities there. But on large projects, really large projects, maybe at a campus level, you're going to have access to data that you've never had before, that's been buried in in drawings and manually created and probably just marked up in Bluebeam, frankly.
Absolutely. And Aaron, as we're starting to close out here, wanted to ask, what are the key considerations for achieving seamless coordination of multi-material models at LOD 400 during construction? Because we've talked about, right, the initial design process all the way down to any, delegated work, but now getting into construction, right? It seems like there's going to be different challenges there compared to the rest of the cycle.
Yeah, and this goes back to a little bit of the earlier conversation we were having about like incentivizing folks to pitch in and help solve problems, right? So I'd say that's the first part. You need to have the right people at the table who can come up with ideas that are actionable in terms of coordination. Going back to that discussion we had earlier about that wall with the steel and the rebar, and just the challenges of the formwork and everything else, and the pouring sequence. Right, we had people at the table that just weren't interested in solving the problem, or really didn't even understand the problem in a lot of ways. So getting the right people at the table. They also have to have this decision-making authority, right? So if you're in a room and you've got, I don't know, mechanical sub, and you've got the mechanical engineer and the structural engineer and the architect, like, do we have to go back to the office and check things with, the PIC or the PM, or can we make the decision right there, right then, to get rid of this coordination issue? So I think that's a big part of it. And then just, how are we going to compensate folks for that? Because there is going to be rework, because we're solving the problem virtually before it gets out to the field. So before, it was kind of buried in either lost days or, hey, this pour got pushed off another day because the rebar didn't get placed or something else. And it was kind of buried in those costs. And now we're pulling that forward and saying, no, that's a cost to the detailers and the folks that are generating these LD 300 and 400 models. So it's a different cost structure. And again, that goes back to some of the challenges that we've got in the industry.
And again, communication, like I said, the common theme throughout this entire conversation, and one that I think everybody can learn a lot from. And Aaron, thank you again so much for taking the time today. What final piece of advice can you give to engineers and other AEC professionals to thrive in an increasingly digital and model-driven environment?
Boy, good question. I think a couple of things is, one is patience, right? We've been in this industry for the way of working in this industry for a long time. And so, people are used to working the way we work, and this new way of working really challenges some of that. One example I'll throw out there is on one of the projects, when we issued the drawings, the steel and concrete drawings, at the exact same time we issued the shop drawings associated with the steel and the rebar, right? And they were actually signed by the engineer, or stamped by the engineer, sorry. So we issued that to the contractor, and the contractor said, well, what do I do now? Right? The engineers already approved it. So the GC is getting the shop drawing. So they still had to route it to the architect and make sure there were no modifications. But it really kind of just, turned the schedule a little bit on its head, because the shop drawings have already been approved. I think the other thing is really kind of leaning into this idea of, contributing to the broader understanding of the project and the success of the project, right? Our projects are complicated, they're fast moving, and anything we can do to help one another to understand the project more, whether it be sharing, quantities or square footages or LD 300, 400 models, is really just kind of leaning into this concept of kind of creating a common understanding of the project to be built, as opposed to holding our cards close to our chest and not sharing information because that's risky. Right? I think we're kind of shifting that thought process 180 degrees, saying, hey, it's riskier if we don't all understand the project that we want to build.
Really well said, Aaron. And, thank you again so much for taking the time today. This has been a really insightful conversation for me, just because it's not like an area of my practice that I get a lot of exposure to. And I'm sure some of the audience will be able to say the same. But if the audience does want to connect with you, what is the best way to reach you?
Phone call, email is probably the best way. I am on LinkedIn, and I check it kind of periodically, but I'm not a voracious LinkedIn person. So yeah, phone call, email is definitely the best.
Wonderful. And of course, like to share any of that info, we can definitely include it in the show notes for the audience. But until next time, I wish you all the best in your engineering and technology endeavors. Thank you, Aaron.
Thanks, Nick. I'll see you.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.